JSON stands for JavaScript Object Notation. It is an easy-to-read format for storing and transferring data. In web development, it is very common to be working with the JSON format. We have already seen what JSON looks like if we open up our package.json. In a JSON file, you're going to have key value pairs, very similar to an object literal. One slight difference is that in JSON files, the keys also need to be surrounded by double quotes, where in our object literals, we did not need to do that. In TypeScript, working with JSON is very simple as there's native support built straight into the language. Let's consider this code where we have an employee object with a first name, last name, and email. In order to convert this object into a JSON string, we can simply use the method json.stringify and provide it any object we want. We run our code, and in the console we have the JSON string printed, and notice this time the keys have double quotes around them, as that is true to the JSON format. Now what if we already have a JSON string, and we want to convert from that string to an actual object? In order to do that, we can use json.parse, we can provide it the JSON string, and it will convert that string into an actual object that we can work with. Now we can run the code, and this time for the object, it prints a little bit differently as it's not just a JSON string, it's an actual object that we can work with. When working with this object, we currently don't have any type safety though. json.parse can be used to parse any sort of JSON string and convert it into an object. And so if we want type safety, we need to know exactly what the type is for what we're parsing, and then we can provide that type. So currently, we can see the type of our object is of type any, but we know that this JSON string is actually an employee. So for us, we can just go ahead and say it's of type employee, and that will give us better type safety when working with this object now. In using an interface, you do run a slight risk when parsing, as there's nothing validating and actually ensuring it conforms to that interface. But in order to actually provide those checks, that would be additional work that we could do if we didn't trust the data coming into us. Now, the JSON format became really big in web development for two reasons. The first is that JSON data is very easy to read. And the second is that JavaScript, and by extension TypeScript, have native support for JSON built right into them. This is a huge advantage because the only programming language that browsers understand is JavaScript. Since JavaScript rules the web and JavaScript has native support for JSON, JSON is very popular. Now there is something I want you to consider when working with JSON. JSON is easy to read, but it's not exactly the most efficient for storage. If you look at the JSON string, we have all of the keys written out. Now here we just have one object. But what happens if you have a million objects? If you have a million objects, do you really need the key first name to be duplicated inside of every single object? In this case, JSON is actually not the most efficient. Storing those keys over and over and over for every object isn't practical. Something like CSV, where you're only storing the values, would be a much more efficient solution for storing these large amounts of data. Now, in all reality, a lot of times when we're storing data like this, we're actually going to be working with a database, so this isn't really an issue. And then on top of that, in web development, we're usually not transferring large amounts of data. Usually what we're doing is we're working with small amounts of data at a time, where the benefit of having that data readable outweighs the con of having it slightly wasteful in storage.